Hi everyone. Happy to be here. So I don't. Where is the thing? Oh, here. Sorry. Cool. Let me get started. So I'm Bryan, flying from New Zealand, and my GitHub handle is XLC. Some people may find that more familiar. So let me get started. So yeah, the agenda pretty logical. So let's start with the problems. So I think it's quite obvious to everyone that for Web3 we need a better user experience. And oops, something is not exactly right, but anyway. So let me take one example of how a typical thing that might happen to a user, like a simple task add a proxy, which is a very useful feature that is underutilized. You might want to do that to improve the security of your account. So how are you going to do that? You collect add proxies, collect buttons. You'll see like, I'm going to add proxy to this account, send the transactions, and oops, it doesn't work. I'm pretty sure this have happened to many people before. And you really, it's very frustrating that it doesn't work, you don't know why. Similarly, the developer experience is also not that great, right? So there's another thing that happens to me multiple times for myself. Yes, so someone reports there's a bug on XCM, something doesn't work on the mainnet. I'm being tasked to debug the thing, figure out what's wrong. So the first stage, it must be my fault. So I check the code. Look the test, everything looks fine. I don't know what's wrong. Maybe it's not my fault. That happened. XCM code could be wrong. So I check it. It looks fine, kind of figure out why it's wrong. Try to find unit test, it's not there anyway. Now the next thing, try to reproduce this locally so I can actually debug and figure out exactly what's going on. So that is also a very tedious process that involving setting up relations, setting up multiple power chains, setting up things, setting up channels, blah, blah, blah. I literally wrote this power chain launch the tools to help to make the process easier, but that's still going to take some time. And sometimes it fails on production, but it works on locally, and that happens a lot of time, which is frustrating. So you're asking for help, and no one actually can help you. That's not good. Yeah. What's next? So a lot of problems can be drilled down into two categories. One is the visibilities. That is knowing what's going on. That you want to see why it failed, how things are being executed. You want to trace it. And similarly, a lot of time you want to know what it's going to do before you submit transaction. For example, you want to make a complicated proposals to the governance. You want to make sure it works, but it's sometimes hard to make sure that it's happening. And another issue is productivity. It can take a lot of time to set up testing environments, doing a lot of things. And to test one thing, you figure out this might be the bug, change it, and spend half hours to compile, upgrade, change, set up new thing, try it doesn't work. Oops, try it again, change it to something else. Spend another half hours, it's still not working. Yeah, half day is gone. That happens a lot of time, especially you want to recompile things. So this iteration feedback loop is super important. Otherwise, people are just wasting time instead of fixing the bugs. I tried. This is from 2020. I was trying to see if there's a solution, like how to dry run transition, so we can know what's going on before we submit the transition. I literally write this myself because no one is doing that. This solution doesn't really work, so yeah. So then, 2022, I wrote another issue because I was looking at Ethereum developer experience. Everyone is using truffles and other things to simulate transitions on local testnet so they can try locally before do it on the mainnet. And we don't have such tools on Substrate. We need one. So yeah, there's a Substrate, Chopsticks there, the missing Substrate testing clients there we are building. So the goal is that we can fork any network for testing, not just power chains, but also relay chains. We can also not fork just one network, but multiple of them. So we can actually test XCMs, which obviously requires multiple chains. Can be like, for example, one more advanced XCMs, like you send to relay chain send to another chain, so you need 3 networks. We want to be able to dry run transitions so we can, know what it's going to do before submit to mainnet. Sometimes you want to debug. Some users say, hey, I want to do this, but it doesn't work. You try it, it works for your account. So there's abilities to disable the signature verification so that you can impersonate you as some other users to see submit transition on other accounts' behalf to debug things. So this is also super useful for front-end development. As well as override wasm, so you can try your new runtimes to see if that works. And the goal is, we want to make this run inside a browser. So we want Chopsticks to be able to help developers' life, and obviously, very importantly, our life. So this I'm going to show how we're using Chopsticks to make our life testing easier. So we have a new product called Asset Router that is able to route assets to accounts on different chains, including power chains as well as other layer 1, layer 2s via the one-hole token bridge. I'm not going to talk too much about this right now because of time. So to imagine how you're going to test multi-chain protocols involving Ethereum's Acala, some other bunch of power chains, like we need to Ethereum testnet, we need to relation testnet so we can run power chain attached with it. And then, of course, Acala power chain testnet and other destination power chain testnet. And then this configuration, deploying contracts. There's a lot of work. With Chopsticks, things can be very easy because we already, of course, have the testnet with one host contract deployed and maintained and connecting to other testnets so to actually testing the one host contracts. So we can just take this Acala testnet, fork it, connecting to, for example, Hydra DX mainnet using Chopsticks. And then we can, because we can arbitrarily set which block to fork on, so we can, for example, start the one-hole transitions on the Ethereum testnet, sending to Acala testnet, and then say it arrives on block 100. Then we fork on block 99. And then we manually replay the transitions. Or, for example, we can deploy the Asset Router contracts and then replay the transitions, and then see if that works. And if it doesn't work, that's fine. We just rewind the block and try it again until it works. And it just literally one line of code, one RPC code to rewind the blocks. So that makes a lot of testing much, much easier. But more problems. Another problem at least me experiencing a lot is slow RPC, because I live on the edge of the world that like most RPC servers live, I don't know, US, Europe, that I constantly getting the ping of 200 to 300 for most of the RPC nodes. They're just slow for me. It also doesn't really scale. There are ways to scale them, but they're expensive. It takes expertise, a lot of additional specialties to run them. And of course, the long-term solutions like clients, but unfortunately, they are not really production ready right now. And there's many use cases just not suitable for like clients. For example, you don't have access to archive data. So the Substrate RPC offers RPC functionality, but it's not really meant for production usage. If you run a Web2 RPC servers, you will know that there are a lot of additional things you need to have to set up a public RPC servers. Otherwise, it can easily go wrong. Like including SSL rate limiting, otherwise might DOS them. You might want caching to improve performance, load balancing failover, a lot of things. And previously, we have a lot of middleware to handle those problems for Web2 servers. Some of them support WebSockets, but none of them have purpose-built support for JSON RPCs. So they cannot support things like caching. So again, I asked this question in 2019. And there's a solution. Someone's building a JSON RPC proxies that mean to solve this. Unfortunately, the project is discontinued, so yeah, I just need to do myself. Subway, Substrate JSON RPC gateway. So I'm talking quick because I don't have a lot of time. So this means to be a general purpose JSON RPC proxy. But of course, it's built for Substrate. But while we're at there, we can also support Ethereum RPCs. So it works for Acala RPC as well as Acala EVM Plus RPC and the normal Ethereum RPCs. So we have the deployment on like 1/3 of our production nodes. There's some data gathered from our Decoded dashboard. So we see like 400 requests per second each, and this is 10% of the sampling rate. So the real number is 4,000 requests per second. Yeah, let me know why like the people spending the author pending exchange there. But yeah, it definitely helps a lot to improve the stability of RPC nodes, reduce CPU load size, improve response time, because like, for example, get headers, like 99% of them are cached locally, like get blocks, a lot of them are cached locally. That just significantly improve the experience for our user and improve the stabilities of our servers, and of course reduce the cost. That not only works for public RPC servers, but at least for me, improve my personal developer experience as well. So we are building this end-to-end testing framework, allow us to continuously testing end-to-end use case in the Polkadot and Kusama. So this allows ensuring us the XCM transition always works. Like, for example, if someone do a runtime upgrade, breaks something, this test will detect it and let us know. So itself is using Chopsticks for the mainnet to perform testing, and it's also be able to test upcoming runtime versions because like, a lot of people are upgrading XCM versions, so this is also super useful for them. It's obviously doing a lot of testing like between Acala and HydraDex, Interlay, A-Star, Kusama, Staming. There's a lot of tests. And it's making a lot of RPC calls, and a lot of them are, duplicated. They are the same RPC, repeatedly making the test, especially when I'm developing tests. Obviously, I'm going to rerun them multiple times. Right now, Chopsticks isn't really optimized to reduce RPC costs. Like, if it's requesting the next 1,000 keys, it's requesting one by one. We don't have time to optimize it. If you want to optimize, please help us. So tests can be slow, especially with large latencies to RPC nodes, which for me is quite bad. So the solution for me is run a local Subway instance because it's able to catch RPC calls. So that, of course, if the call is in the cache, it will just serve me immediately. So that significantly reduce the latency when we run the test. So on the number here, I'm not sure if you can read them clearly, but on the left side, I'm running like 9 tests. And in total takes 153 seconds. On the left side, 153 seconds. On the right side, it's only 33 seconds. So it's significantly reduced test, makes like running them doesn't take forever, so I can spend more time writing tests instead of like staring at the computer and thinking something else, the meaning of life. So what's the future plans for the tools? Chopsticks, it was initially built as a testing tool, helps serving this purpose of allow developers easily testing the code and the new runtimes. But as we are working on it, we find out it have more potentials. It doesn't need to be limited to be just a testing client, because it have ability to simulate transitions, and because the way we build it, it can be compiled into a version and run inside a browser, inside extensions. Not yet right now, but will be happening at some stage. So they enable a lot of interesting use cases. For example, preview the transition outcome. We're talking with like browser extensions, like Talisman guys, about integrating Chopsticks so that before user signing transition, right now it shows you like the transition going to sign. But as an example I showed you previously on the add proxy examples, it doesn't really doesn't necessarily tell you if the transition is going to fail or not, what's the outcome of the transitions. But with Chopsticks, it's possible to just write around the transitions and it will be able to give you the whole, not only events, but also modified state. So you will see the user balance will be reduced by this amount. Like if you do a swap, you will see this balance reduce, this balance increase, some like validators or collators get some fees or something like that. So you will exactly know what's going to happen. Of course, ignoring like people front run your transactions, but otherwise you will exactly know what's going to happen. And you can actually do this using Chopsticks locally. There's some special flag to print you the thing, but it's more useful if it can be actually integrated into the normal signing process, allow user to preview them. Not only limiting to the local transactions, we're making a lot of XCM transfers, for example, right now. It can success on the source chain, send XCM, like charge the fund, send XCM, fail to be executed on the destination chain, especially, for example, they just did a runtime upgrade, something broke. That's bad for users, like that fund are lost. So with Chopsticks, with XCM simulation abilities, we can just simulate the transaction on source chain, see it's going to send XCM, simulate on destination chain, and tell user if that's going to work or not. Like preview governance proposals, like the one I told before, like the new collective fellowships on Polkadot, there's one super complicated transaction proposals that send XCM to relations and send XCM to the bridge hub to do a runtime upgrade. We can use Chopsticks to help with this. Trace execution and figure out what's wrong. Wasn't few functions, so there's another thing that could be used to run some wasn't blob and tell you what's the outcome. Subway. So obviously, the future for dApps and wallets is definitely like clients. All the dApps and wallets should integrate like clients when it's mature and ready. But it's like clients not the silver bullets for all the use cases. It's suitable for many use cases, but not all the use cases. So we're still going to need some RPC nodes. Like for example, if you run your private instance, you want some some scrap monitor blockchains. You might want to use your own private RPC nodes because that like clients still have limitations. I would say when the Subway right now is not exactly production ready, but when it is, definitely I would suggest everyone just put a Subway instance in front of the RPC nodes. That can, for simple things, it makes cache a server, reduce server load, but as well, failovers. You can configure your Subway to connect to multiple upstream nodes. If one of them is broken, then you can switch to something else. And then so your scrap logic does not need to implement this once more. So that just makes a lot of things much easier. Otherwise, right now, our servers always need to configure with multiple RPC nodes just in case something goes wrong, which does happen with the new versions. They're not very stable. So with this, the client does not need to have any of this logic at all. And if the public knows, you can separate them and make things easier. So that concludes my talk for today, and thanks for listening.